Hi, everybody. In this lesson, we are going to go back through some of the stuff in 10.1 and 10.2 that we glossed over, specifically a topic called phase plane analysis. Before we get to that, though, I want to review the idea of independent versus dependent variables. Now, I'm sure you're already familiar with that terminology, but it's important to really thoroughly understand it for this topic, so I wanted to review it. The independent variable can be anything, but the value of the dependent variable depends on the value of the independent variable. That's why we call the other one the dependent variable. So for example, in the equation of the function y equals 2x, we can put anything in for x. That's the independent variable. And after we put in a value for x, we then can compute a value for y. That's called the dependent variable. Now, if we graph that, so we're used to doing it this way. The horizontal axis is x, the vertical axis is y, and we have the line y equals 2x, which is going to look like this. Notice that we have made the horizontal axis for the independent variable, and the vertical axis we've made for the dependent variable. In this class, we've also learned about functions of two variables, which is a function where one variable, usually called z, is the dependent variable because it depends on the values of two independent variables. And in this case, we have, if we graph it, the upper half of a sphere. So I can tell it's a sphere because if I square both sides, I get z squared equals 4 minus x squared minus y squared. And if I add an x squared and a y squared to both sides, that gives me x squared plus y squared plus z squared equals 4. I'll write that as 2 squared just to make it really clear that the radius is 2. So let's graph that. And by the way, if you have trouble graphing circles or spheres, I got this great piece of advice from one of my favorite professors when I was a student. And what he said to do to get a nice graph was to graph the circle or the sphere first and then put in your axes. In this particular case, our sphere is centered at the origin, so my axes should go right through the origin, and then I can mark what the radius is after I've put the axes in. And as we said, this is just the upper half, so let me take away the bottom half of the sphere. Okay, there we go. Now, again, with independent variables, they can be anything, well, technically anything that's in the domain. And then the value of the other one, and I should really label my axes, shouldn't I? Anyway, then the value of the dependent one depends on the other two. So for example, the reason we have this point up here is that z equals 2 if you plug in 0, 0 for x and y. I hope that makes sense. And let's notice that our vertical axis is the dependent variable axis, and our two horizontal axes are the independent variable axes.